In this video, we're going to look at the method of finding integrals by partial fraction decomposition. So you're going to look at something like this, the integral of 1 divided by x squared minus 5x plus 6 dx. And this doesn't look that bad right off the bat, and you may be thinking it could be something like a natural log, but if you look at it closely, in order to have that u prime over u, you would need a 2x minus 5 on top, which you don't have, so we can't take that route. It turns out if you want to solve this by the methods we've learned so far, you can do it by completing the square and using trigonometric substitution, which I know is not exactly everybody's favorite process. For this particular problem, the process looks a little something like this. You can see that it's very long and tedious, and maybe not the best way to go. I'm not going to walk you through all of that. If you're interested, just pause the video and make your way through it, but we're going to look at another method for doing this. This is what we call the method of partial fraction decomposition, and it all hinges on the fact that 1 over x squared minus 5x plus 6 is equal to 1 over x minus 3 minus 1 over x minus 2. And because those two functions are equal, we can then turn this into the integral of the right-hand side. And then I can split it into two integrals, 1 over x minus 3 and the integral of 1 over x minus 2 dx with a minus in the middle. And then for the integral on the left, we could allow u to be x minus 3, so u prime would just be 1, which we have. For the integral on the right, we could let u be x minus 2, so u prime would be 1, which we have. So both of these become that u prime over u dx integral that we're familiar with, and we know that that evaluates to be the natural log of the absolute value of whatever u is. So we would have the natural log of the absolute value of x minus 3 minus the natural log of the absolute value of x minus 2, all plus a constant, of course, because this is indefinite integration. And then using the rules of logarithms, because these two are subtracted, we can collapse this to be the natural log of the absolute value of x minus 3 over x minus 2 plus c. And if you flash back to that first method, you'll see that you do get the same answer. They are equivalent. This is a lot easier than the previous method. However, if you don't know this fact up here, then you can't really use this. So what we're going to talk about is how to take something like this, 1 over x squared minus 5x plus 6, and break it down or decompose it into its partial fractions so that you can integrate using the natural log rule. From your studies in algebra, you may recall that if you have a polynomial with real coefficients, then that polynomial can be factored into linear and irreducible quadratic factors. So what that means is something like x to the 5th plus x to the 4th minus x minus 1, that's a polynomial of degree 5 with all real coefficients, can be written as x minus 1 times x plus 1 squared times x squared plus 1. These two factors are linear, and this one is an irreducible quadratic, meaning that it can't be factored any further. So if you had a function that is some polynomial of degree less than 5 with the denominator of this function, then you can reduce this to be some series of either constants or polynomials of degree 1 divided by the different factors here. So a decomposition works this way. Whenever you have an improper improper rational expression, meaning the degree of n is higher than the degree of d, then you would first start by long dividing until you can get it to where that's not the case. Then whatever denominator you have left, you're going to completely factor the denominator into factors of the form px plus q to the m or ax squared plus bx plus c to the n, where this is unfactorable. Any time you have a linear factor, you're going to have some constant over that factor, and if it's of a degree higher than 1, you would have that many copies of it with different constants on top. And anytime you have a quadratic factor, you're going to use the form bx plus c over the quadratic factor, and again you may have to repeat that if you have a higher power of that quadratic factor. So we're going to look at some of the different scenarios that you may see arise with these problems. So for example, this one says find the integral of 1 over x squared plus 6x plus 5 with respect to x. So the first thing that you want to do is start by factoring your denominator. So if you need to review your factoring skills, I would highly recommend that you do that. X squared plus 6x plus 5 is going to be written as x plus 5 times x plus 1. Then I'm going to take the expression, the rational function, or the rational expression, and I'm going to rewrite that as, because both of these are linear factors and they only have a power of 1, I'll have some a over x plus 5 plus some b over x plus 1. And that's going to be what our decomposition is going to take the form of. Now, your next goal, and you might want to rewrite this as the factored version for this step. Our next goal is to completely clear the denominators. So to do that, I'm going to multiply every term by the least common multiple, which is always going to be completely whatever the denominator is on the left side. So I'll multiply this by x plus 5 times x plus 1. I'll multiply this by x plus 5 times x plus 1. And I'll multiply this by x plus 5 times x plus 1. So you can see that that'll cancel everything here. It will cancel the x plus 5 here, and it will cancel the x plus 1 here. So now I'm left with 1 equals a times x plus 1 plus b times x plus 5. Now there's a couple of different ways that you can solve for a and b here. One way that you can do this is you can multiply everything out and then equate the corresponding coefficients of x, so like the coefficient of x squared, the coefficient of x, the constant terms, and find some kind of system of equations to solve. But in a situation like this, there is a shortcut method whenever you have these linear factors like this. So if I want to find a, my goal is to make the b disappear. I'm going to choose a value of x that will make the b disappear but not the a. So if I were to let x be -5, that would make this parentheses equal 0, and this one would be a -4, so we wouldn't have a problem there. So I'm going to choose x equals -5. I'm going to plug that in, so I'll have a times -5 plus 1 plus b times -5 plus 5. So this gives me 1 equals -4a plus 0b. And then if I divide by -4, I get a equals -1/4. Now I want to find b, and I'm going to do something very similarly. I'm going to choose x equals -1. I can choose this because this has to work for all real x for which this function is defined. So I'm going to choose x equals -1, and I'm going to have 1 equals a times -1 plus 1 plus b times -1 plus 5, and I get 1 equals 4b, or b equals 1/4. So that means my partial fraction decomposition is now -1/4 over x plus 5 plus 1/4 over x plus 1. Now if you did this in your Math 112 or your pre-calculus algebra course, you might have brought those 4's down and made it a nice non-complex fraction. But for our purposes, we're just going to leave them on top because we can deal with constants easily in calculus. So now I get to integrate. So the integral of 1 over x squared plus 6x plus 5 dx is now going to be the integral of -1/4 over x plus 5 plus 1/4 over x plus 1 dx. And I can bring the -1/4 out front and integrate 1 over x plus 5 dx. And I can bring the +1/4 out front and integrate 1 over x plus 1 dx. And these are both really simple. U equals x plus 5, so u prime is 1. U equals x plus 1, so u prime is 1. So this one is just negative 1/4 times the natural log of the absolute value of x plus 5 plus 1/4 times the natural log of the absolute value of x plus 1, all plus c. And there's nothing wrong with this answer. This is perfectly valid. You'll see a lot of people will factor and do a little bit of work on this. So they might factor out the 1/4 and make this natural log or negative natural log of the absolute value of x plus 5 plus the natural log of the absolute value of x plus 4, or sorry, x plus 1. And then they might collapse those logarithms to be x plus 1 over x plus 5. And you may even see some people bring this in and make it the 4th root. I tend to stop here. If you stopped here, that would be perfectly fine also. WebAssign should accept that answer, and I would accept that answer. Next, let's look at what happens when you have repeated linear factors. So with this one, I am going to check my numerator has a degree less than my denominator, so I don't need to divide. I do need to factor the denominator, x cubed minus 4x squared plus 4x. And I would start by factoring out the x, which gives me x squared minus 4x plus 4. And then I would factor the trinomial to be x minus 2 squared. So what I'm really looking at now is x squared plus 3x minus 4 over x times x minus 2 squared. And I want to break that down into some factors. So x is linear, x minus 2 is linear, but the x minus 2 is repeated. So I'll have a single a over x for this factor. I'll have a b over x minus 2 for the first copy of x minus 2. And then I'll have a c over x minus 2 squared for the second copy. And if you had had cubed, you would have plus d over x minus 2 cubed. It just keeps going for whatever power you have on that factor. So from here, the process is exactly the same. I'm going to multiply through and try to cancel out the coefficient, or sorry, cancel out the denominator, not the coefficient. So I'll multiply through every single thing by x times x minus 2 squared. And you can see that I've done that for every term. This denominator will cancel all 3 pieces. This one will cancel the x. This one will cancel one copy of the x minus 2. And this one will cancel both copies of the x minus 2. So I'm left with x squared plus 3x minus 4 equals a times x minus 2 squared plus bx times x minus 2 plus cx. Now, use whatever strategy comes to you first. I notice that if I were to let x equal 0, that would get rid of both the b and the c, but it would leave the a alone. So to find a, we'll let x equal 0. So that will give me 0 squared plus 3 times 0 minus 4 equals a times 0 minus 2 squared plus b times 0 minus 2 plus c times 0. So I get negative 4 equals positive 4a plus 0, or a equals negative 1. To find c, I notice that if I were to let x equal 2, that would get rid of the a and the b, but leave the c alone. So we're going to let x equal 2. So we will have 2 squared plus 3 times 2 minus 4 equals a times, well, that's going to be 0 squared plus b times 2 times 0 plus c times 2. The left-hand side adds to be 6, and here we get 2c. So I'll get c equals 3. And you may notice that I've skipped b, because there's nothing I can do at this point to cancel out the a and the c but leave b alone. If I choose either 0 or 2, they would both be there. But now I know the values of a and c, so I can pick any other x, plug it in along with those values, and I can figure out what b has to be. So to find b, we're going to choose any other x. I'm going to choose x equals 1. So I'll have 1 squared plus 3 times 1 minus 4 equals a times 1 minus 2 squared plus b times 1 minus 2 plus c times 1. And then for my a, I'm going to go back and fill in the negative 1. And for my c, I'm going to go back and fill in the 3. So on the left-hand side, I get 1 plus 3 minus 4, which is 0. Here I'll have negative 1 times 1 plus, let's see, that's going to be b times 1 times negative 1, so that's negative b plus 3. Adding the constants, I get 2 minus b equals 0. If I subtract the 2, I get the negative 2 equals negative b. And if I divide by negative 1, I get 2 equals b. So my decomposition comes down to a over x, so that's negative 1 over x, plus b over x minus 2, plus c over x minus 2 squared. So now I just need to integrate that. So the integral of our original function, which was x squared plus 3x minus 4 divided by x cubed minus 4x squared plus 4x dx, is now going to be the integral of negative 1 over x dx, that's just the a, plus the integral of 2 over x minus 2 dx, plus the integral of 3 over x minus 2 squared dx. Okay, so let's deal with each of these integrals. The first thing I'm going to do is convert them to something that I know how to integrate by moving some constants around or moving some exponents around. So here, I would have negative 1 times the integral of 1 over x dx, plus 2 times the integral of 1 over x minus 2 dx, plus 3 times the integral of, let's make this one x minus 2 to the negative 2 power dx, because that's something we know how to integrate, and we can just pop that term up as long as we change the sign of the exponent. So this first one will give me negative natural log of the absolute value of x. Here we'll have 2 times the natural log of the absolute value of x minus 2. For this one, u would be x minus 2, so du is going to be 1 dx. We have what we need there. So this is just going to be a u to the negative 2 integral. So we'll have x minus 2 to the negative 1 over negative 1. And that's all plus c. Now I can do a little bit of work on this. I can bring the 2 in and square it. And since we're squaring it, we can drop the absolute value symbol. Then this one will become minus 3 over x minus 2 to the first power. And then I can combine these two using logarithm rules, and I'll have the natural log of x minus 2 squared over the absolute value of x minus 3 over x minus 2 plus c. And that will be my final answer.